The trip from Earth to space and back again is a journey through an environment of extreme pressures and temperatures. The job of simulating those extremes and of testing materials to safeguard space travellers from them is done here at the Atmospheric and Re-entry Materials and Structures Test Facility. Inside of the facility's two thermal vacuum chambers, technicians can achieve the same atmospheric compositions and thermal conditions of any known planet. The ability to produce atmospheric extremes such as temperatures up to 4,000 degrees Fahrenheit allows technicians to subject potential spacecraft materials to realistic stresses. The hazardous conditions simulated are not the only perils of spaceflight. Technicians study a completely different danger confronting those who venture into orbit, especially those who leave their spacecraft. Although spacewalking astronauts look as though they're barely moving through space, they're actually travelling at more than 17,500 miles per hour. At velocities like these, micrometeoroids and tiny bits of space debris could pass through a spacesuit like a bullet if precautions were not taken. To determine if the material can provide the necessary level of protection, it must be subjected to rigorous impact testing, and that's done here at the Hypervelocity Impact Research Laboratory. The facility's three-light gas guns are capable of accelerating projectiles ranging in size from 300 microns to 3/8 of an inch at velocities of up to 4.5 miles per second. The Hypervelocity Impact Research Laboratory is instrumental in the design of shielding systems for NASA spacecraft like Space Station Freedom. This computer simulation of a high-speed flight across the Los Angeles vicinity was produced to demonstrate a capability of scientific data visualization used in interplanetary exploration. The entire animation was produced from one Landsat satellite image from 950 kilometers that was merged with digital elevation information. This is Los Angeles, California, and we're traveling towards the Pacific Ocean at about 300,000 kilometers per hour, and will drop behind Santa Catalina Island about 40 kilometers off the coast of Los Angeles. We're flying over the island, and then we'll cross the coast north of the Santa Monica Mountains. As we head south, we can see features like Marina del Rey and LA International Airport. There's the Long Beach Harbor, and now the Orange County area. The bow tie features are Balboa and Lido Islands on Newport Bay. In the center of screen is downtown LA. And now we're over Hollywood and Beverly Hills as we move into the San Fernando Valley. You'll see a V-shaped lake appear. That's Castaic Lake. We will now turn and fly directly down the Rift Valley of the San Andreas Fault. We're crossing the east fork of the San Gabriel Mountains, and we'll turn around and face those same mountains when we lose elevation into the Pomona Valley area. In the top right of screen is Mount Baldy, and as we pan the San Gabriel Mountains, we can note in the foreground the Santa Fe Dam and Recreation Area, the Santa Anita Racetrack and Golf Course. And that little white donut is the Rose Bowl. The year is 1973. Man's first home in space Skylab is in orbit. Throughout the 3 Skylab missions, flight crews conducted experiments in medicine, Earth observation, engineering, solar physics, and astrophysics. The technology developed during Skylab provided the basis for the design and development of future long-duration space stations. In addition to providing a laboratory for important studies, Skylab marked a significant transition in the spaceflight program. In each Skylab mission, astronauts became workers rather than observers. Skylab also provided a testing ground for techniques and equipment that would be needed for man to work effectively in space. One of the tools tested, the Astro Manouvering unit, would prove its usefulness on future flights of the space shuttle. The Astronaut Manouvering Unit tested on Skylab is now known as the Manned Maneuvering Unit, or MMU. Its first test in open space is about to begin. Here, astronaut McCandless was over 100 meters out from the spacecraft. He had proven the Manned Maneuvering Unit could be flown in space, and he simulated something very important. He travelled the same distance another astronaut would have to travel 2 months later to get from the shuttle to an ailing NASA satellite. The giant Antonov 225 took off from an airport outside Kiev and flew for 15 minutes before landing safely. The heavily reworked plane was originally designed to carry the former Soviet Union's Buran space shuttle. Industry experts say the AN-225, dubbed Mriya or Dream, can carry 250 tons of cargo that is equivalent to the weight of 250 small family cars and could increase the size of that lucrative market. Test pilot Alexei Shulshenko expressed his enthusiasm after safely landing the plane. Antonov Airlines, an airline affiliated with the Antonov Design Bureau, has said that the Mriya could be hauling commercial cargoes very soon. Antonov is also the designer of the AN-124-100, the largest plane currently in commercial use, a 120-ton capacity freighter known also as the Ruslan. The AN-124 is aimed at a niche market for super heavy and oversized air cargo, which is worth more than $200 million a year and is dominated by Russian and Ukrainian carriers. Russia's Volga-Dnepr Airlines, which controls the lion's share of the super heavy air cargo market, has also said it is interested in cooperating with Antonov to bring the AN-225 into commercial use. The plane was launched in 1988 as part of the former Soviet Union's space program. Just 2 such planes were built, and only 1 actually flew. The Turbo AN225's wingspan is 88.4 meters, and the plane can carry its maximum cargo for up to 4,500 kilometers at a cruising speed of 800 to 850 kilometers per hour. With a lower payload of 150 tons, the range extends to 7,000 kilometers. Cargo can be carried both inside and outside the plane. Every year, nearly 500,000 Americans suffer sudden cardiac arrest. The heart begins to beat erratically, losing its ability to pump blood. Often the only hope for revival is a defibrillator, sending electrical shocks to the heart that can restore normal rhythm. In the past, those fortunate to live through an episode like this faced more bad news, a 50-50 chance of it happening again within 2 years. Today, these odds can be reduced to about 2% thanks to this automatic implantable cardiodiverter defibrillator, or AICD. Incorporating a variety of NASA-developed techniques, the device consists of a pulse generator and a series of wire leads all implanted in the body. The generator, about the size of a deck of cards, is inserted under the skin in the abdomen. Leads connected to the generator are sewn onto or placed inside the heart. Once implanted, the AICD continually monitors cardiac activity, delivering corrective electrical shocks anytime erratic rhythms occur. According to doctors, more than half of the patients so treated received a shock within the first 2 years. Michael Ladira is one of these patients. He runs his own air conditioning and heating company. He describes the shock delivered by his implanted device as akin to a kick in the chest. Not pleasant, but something you recover from quickly. His job requires spending time at different construction sites. His active lifestyle, both within and out of the workplace, made the AICD a logical choice. The AICD is manufactured by Cardiac Pacemakers Incorporated from Minnesota. Microelectronics, microcomputer, battery and telemetry technologies originally developed for the space program are all incorporated. Since those original discoveries during the early moon flights, more than 25,000 people have received AICDs and a new lease on life. Don Gallagher believes that every time his device goes off, it literally saves his life. And the fact that Gallagher's AICD has gone off 50 times in 4 years leaves him in no doubt as to the value of the technology. This astronaut is landing the space shuttle for the 5th time today. It's the shuttle mission's simulator's motion-based cruise station. Once assigned a flight, a crew will log as many as 300 hours in this high-tech trainer before liftoff. And as launch day nears, the training grows even more realistic at the SMS. The shuttle mission simulator is linked by computer to mission control, allowing flight controllers to interact with the crew using actual mission software. But the most realistic aspect of the SMS is its ability to simulate the physical experiences of the different phases of a mission, such as the turbulence of launch and ascent. The SMS will continue to help NASA train their pilots for space flights now and in the future. This is the Life Support System facility. A high-altitude chamber converted into a living space for NASA's Phase 2 mission. It has 3 separate stories comprising of 1,000 square feet of living area. The principal objective of this ground-based mission was to recycle all the air and water inside the chamber for 30 days, beginning with enough air and water for only 1 week. Preparing for the test was an exciting time for the 4-person crew. They went through extensive training, not only on the systems, but also on things like microbiological samplings. As members of the backup crew looked on, the samplings became even stranger. And while there were many enjoyable aspects to the month-long mission, nose swabs were definitely not one of them. As part of the traditional ceremony on entry day, the crew cut a cake on behalf of all mission personnel. At door closure, all the team managers were on hand to make sure the chamber was sealed up tight. The crew was bemused to see so many NASA executives on hand to make sure that they weren't going anywhere. Round-the-clock monitoring and operations support throughout the mission was provided by an exceptional test team located in a 20-foot control chamber close to the Life Support System facility. The crew's water use was heavily regulated. Approximately 0.1 to 2 gallons was dedicated for hand washes. The Phase 2 team of Kathy Hurlbert, John Lewis, Doug Ming and Pat O'Rea spent a lot of time together in the common area on the first level. It's where they ate their meals, conducted press conferences, held group meetings and enjoyed their limited leisure time. This was the 3rd level restroom, and to call it basic would be an understatement. Similar to today's space station bathrooms, which it in fact helped to design, it uses a simple waste removal system and funnel. Hand washing had to be done quickly before the predetermined quota of water would run out. The entire aim behind the mission was to see how long air and water could be recycled and maintained, so every drop was vital. And once water was used, it needed to be logged in order to help scientists on the outside determine how efficient the life support systems were functioning inside the chamber. The 3rd level contained the crew's quarters. It was their home away from home, where they slept, read, worked, and on occasions hid. With the use of the internet and telephones, they were still able to communicate with the outside world. On October 4, 1957, the Soviet Union launched Sputnik 1, the first artificial satellite. The Soviets' launch is for the International Geophysical Year, or IGY. The geophysical year is 18 months from July 1957 to December 1958. More than 70 nations and as many as 70,000 scientists cooperate to investigate the world and its environment. Sputnik 1 concerned America because of the far-reaching technical and military implications of the launch. Less than a month after the first Sputnik, Russia launched a second Sputnik, which weighed about a half a ton and carried a dog as a passenger. This Sputnik caused even more concern for America because of the size of the satellite. During IGY, the United States planned to launch a Vanguard satellite which weighed just a little over 3 pounds. The attempt to launch the Vanguard on December 6, 1957 ended in failure in a ball of flame and wreckage. Following the disaster, a team including Dr. Werner von Braun from the Army's Redstone Arsenal were given their long-sought chance, the go-ahead to launch an American satellite. They used their flight-proven Jupiter-C rocket launcher. At Cape Canaveral in late January 1958, the covered satellite known as Explorer 1 is placed atop the Jupiter-C, poised on Pad 26 for firing. Explorer 1 is to be about 30 pounds in orbit, but severe winds cause a 2-day postponement. Then on January 31st, 1958, the United States answers the Soviet challenge in space. Explorer makes a major discovery, a radiation belt around the Earth. Dr. James Van Allen from the University of Iowa identifies the region. The finding of the Van Allen belt is an important finding of the International Geophysical Year. The crew of STS-112 from NASA were guests of honour at the UK's National Space Centre. They had recently returned from a mission to take and install a 45-foot truss to the International Space Station. Amongst them were British astronaut Piers Sellers, who performed 3 spacewalks to attach the truss. He said it was an unbelievable experience. The first time out, the hatch was quite incredible. You open the big circular hatch in the floor, lift it up, and you're looking straight down 240 miles, and there's the whole world going by at 5 miles a second. He added that you then just dive out slowly through the hatch, float out into space, grab hold of a handrail. You find yourself hanging under the ship, which is barreling over the Earth very fast, just hanging by a handle and looking at the world go by. For him, it was the most beautiful thing. The space station will be a working laboratory for scientists to undertake experiments for the next 25 years. The crew were welcomed to the UK's National Space Centre by astronomer Sir Patrick Moore, who says their work really could take us beyond the final frontier. The hope is that this work will help future generations to boldly go where others have never been before.